Hello, my students and learners in chemistry. Here is another video presentation on an important topic termed as photoelectric effect. Now, as the name itself indicates, photoelectric effect concerns with photo and electricity. Photo means the light effect and the electrical effect. So, what is photoelectric effect? Photoelectric effect surprisingly, is the ejection of electrons when a beam of light is of certain frequency strikes over a metal, and mostly the metal which can show photoelectric effect are highly electropositive metals. Not all the metals will uh, show photoelectric effect, and the electrons which are released, which are emitted by the uh, by the light when it is struck over a metallic surface are known as photoelectrons. Mind it, it's highly positive electrons like cesium, potassium, lithium, sodium, rubidium, etc., which show photoelectric effect. Of course, non-metals will never show photoelectric effect. Now, what are the reasons? We are going to take it up. Now, there is a very simple experiment performed by the great scientist Hertz in 1887. He just performed a simple experiment. Accordingly, a beam of light, maybe ultraviolet light also, uh, when it strikes over a metal, hmm, electrons are released. And in so far as the experiment is concerned, a vacuum chamber was used where the discharge electrodes were uh, present, designed, and one serves as a cathode and the other serves as an anode. The positive term, as we know, are known as anode, and the negative is known as cathode. So, when the light is struck over the metal, the uh, electrons were released from cathode to anode, and the circuit is complete like this. So, the diagram simply represents this Hertz experiment. Okay. Stream of electrons coming over by light effect over the metallic surface. Observation. Now, usually, when an experiment is performed, we observe something. We note down the observations. Now, there are very simple observation about the photoelectric effect. The energy of emitted photons remain unchanged with an increase in intensity of light, incident light. What I mean to say is that uh, light of any brightness, intensity of light is related to brightness of the light. When the light is, the brightness of the light is changed, the energy of the photoelectrons or the emitted photons remains unaltered. It doesn't change. Of course, what happens that when the brightness of the increase light, incident light is increased, the number of photons released per second becomes more. Or you can say the emission of photoelectron is increased by increasing the intensity of the uh, incident light over the metallic surface. The frequency of the incident light, when we plot a graph over the frequency of the incident light and the kinetic energy of the photoelectrons. Photoelectrons, I have already given you an idea, are the electrons which are released from the surface of a metal. Now, no electrons are released when the frequency falls below a certain value. Very important. Frequency of the incident light has to be a certain fixed frequency. Means, and this frequency depends upon the metal or the metallic surface and is known as threshold frequency. Symbolically we represent it by nu naught. This is a Greek letter nu. Naught means the threshold frequency represents. Below this, no electrons would be emitted, ejected. इतना तो फ्रीक्वेंसी होना ही चाहिए. इससे कम होगा किसी मेटल के लिए तो वो इलेक्ट्रॉन रिलीज नहीं होगा. And therefore, if you plot it, we get a straight line like this, and if you draw it back in the towards x-axis, you find the frequency of the light. That is known as threshold frequency. Now, this has been a simple experiment given by Hertz, but explained by Einstein. And what is the Einstein's experiment? Let us see. The energy of the emitted photons remain unchanged with the intensity or brightness of the light. That is what we have just observed. Now, according to the classical theory of physics, this should not occur. As the brightness is increased, the intensity, the energy of photoelectron should also increase. But it doesn't happen. Why? Why this remains unchanged was well explained by what is known as quantum theory of light, given by Einstein in 1905. Einstein, of course, is known to us that he has been a Nobel Prize winner. He was awarded a Nobel Prize on his quantum theory of light. And according to quantum theory of light, the electromagnetic radiations or light travels in bundles of energy, packets of energy, bundles of energy. मतलब ये discrete पैकेट्स ऑफ एनर्जी के रूप में ये लाइट ट्रेवल करती है. ऐसा नहीं है कि लगातार लाइट रिफ्लेक्ट होती हो या चलती रहती हो. इट डजंट मूव दैट वे. थोड़ी सी लाइट पैकेट और बंडल ऑफ एनर्जी इज रिप्रेजेंटेड, एंड दैट एनर्जी, दैट बंडल ऑफ एनर्जी इज नोन एज quanta of energy. Accordingly, the photon of incident light, what happens? The bundles of energy which strike over the metal surface through the light, this is represented as per quantum theory by h nu. Nu is the frequency of the light, and h, of course, is a constant which was given by Planck himself and is known as Planck's constant. And the value of Planck's constant is 6.6261 into 10 to the power minus 34 joules second. And as this bundle of light strikes over the metal surface, it transfers all of its energy to the metallic surface, and without any delay, immediately the electrons are released with a kinetic energy half mv square. So we can say that the bundle of energy which was represented by entire energy possessed by the incident light, in terms of bundles, and that was known as h nu. H nu is equal to half mv square, or you can say nu is directly proportional to kinetic energy. And putting that constant h, we get h nu is equal to half mv square. Greater the intensity of light means greater number of photons are released. अगर इससे ज़्यादा हम लाइट की तीव्रता को बढ़ा देंगे, इंसिडेंट की ब्राइटनेस को बढ़ा देंगे, तो इसका केवल मतलब यही होता है कि फोटोन ज़्यादा निकल रहे हैं, फोटोन की संख्या ज़्यादा हो रही है. Greater intensity of light merely implies greater number of photons, each of which releases one electron. Now let us see what are the conditions which cause photoelectric effect. Primarily, as known to us, electrons are attracted by the nucleus of an atom, and therefore whatever energy we provide over the metallic surface, that should overcome the attractive force exerted by the positive ion of the metal. And only then electrons will be free to come out of the surface or to get emitted. Means enough energy, which is also known as photoelectric threshold, should be provided to the metallic surface. Only then the electrons will be released. And for this, there should be a proper frequency of light which with the light should strike the metallic surface. And that frequency, minimum frequency, which causes photoelectrons to be emitted by a light, is known as nu naught. And if the light is less than this frequency, nothing will happen. Nothing will happen. You won't get any electron to be emitted. Whatever may be the brightness. Brightness doesn't affect the emission of electricity. Okay. For example, green light. Green light which comes within the visible range, the visible spectrum, can cause electrons to be ejected from the metal surface even if the intensity of light was very low or it was shown only for a short time. Now therefore, we find that energy of photon is directly proportional to the frequency of the incident light or electromagnetic radiation. If the frequency is lesser than threshold frequency, you won't get any electron to be emitted. Now, when the frequency is greater than the threshold frequency, suppose the incident light is struck over the metallic surface with a greater frequency than the minimum required frequency, that was threshold frequency, what will happen? Out of the total frequency, a part of energy will be used up to release the electron, and the remaining energy will cause emission of the electron with greater kinetic energy. ज़्यादा तेजी से इलेक्ट्रॉन निकलेंगे. And that expression we can say mathematically that h nu is equal to h nu naught plus half mv square. Now this h nu naught is the threshold frequency and h nu is the actual frequency we are using, and half mv square we know is the kinetic energy with which the photons are released. And we can say that h nu naught is fixed for a particular metallic surface, and this is the minimum energy which is required and this is very commonly termed as work function, denoted by W. Now, rearranging this equation, we can say that half mv square is equal to h nu minus half mv square is equal to h nu minus h nu naught, and that is W. So this is the final equation. And we find that this is the equation of a straight line. And the slope which we get for this straight line is equal to the Planck's constant given by Planck. The value of h was found by Planck himself. Now, what are the conclusions of photoelectric fact? Light radiation is not continuous but discrete. ये लाइट का निकलना लगातार नहीं होता, थोड़ी थोड़ी देर में पैकेट्स के रूप में, बंडल्स के रूप में या डिस्क्रीट फॉर्म में ये बराबर रेडिएट होता रहता है. Photons therefore can be considered as carriers of light. Light radiation has a particle nature. Very important. Light radiation has a particle nature. मतलब ये photon है, means it is acting like a photon. It's striking over the metallic surface with certain energy, and all of its energy is being transferred to the metallic surface immediately without any delay or without any time lag. Electrons are released because the energy provided over the metallic surface had been enough to loosen the attractive force between the positive ion of the nucleus and the electron. Okay, now based upon this, there are certain quizzes provided here. I expect our viewers, including students, to consider it and write the correct answer. And I'll be grateful if you can mail me at my mail ID and come up with your problems or doubts, and we can be in touch with each other. Thank you very much. Please go through it. The topic is very important because based upon this, we can have greater details about absorption spectra and emission spectra of an atom, of an element. Thank you.